Hi, this is Asghar Gori. In this video, I'm going to give you an overview of what special file permission bits are in Linux, their impact on files and directories, and how to apply them on files and directories. I'm going to use my CentOS 7 system called Station 1 for the demonstration portion. I'll be logged in as the root user, and I'll use a software called Screen on the system to split my terminal into two virtual terminals. You may want to install this software with the RPM command on your systems if you like. Okay, please note that the concept of special permission bits is universal and it applies to all Linux distributions. Before we go any further, I'd like to highlight the importance of controlling and regulating the use of these special permission bits on production servers, as their incorrect use may create security issues on the system and for the applications running on the system. For more information, please see my book, RHCSA and RHCE Red Hat Enterprise Linux 7 Training and Exam Preparation Guide for EX200 and EX300 exams, 3rd edition. So what really are the special file permission bits? As we know, Linux offers a standard read, write, and execute permission bits for the owning user, the owning group members, and for the rest of the users on the system, who we collectively call public or other. We also know that these standard permissions have different meanings for files and different meanings for directories. On files, they allow the users to be able to read the contents of a file, modify its contents, and run it if the file is executable. And on directories, the standard permissions allow users to be able to view the listing of a directory, create or modify files under that directory, and be able to change into that directory using the cd command. That's what the standard file and directory permissions are in Linux. In addition to the standard permissions, Linux offers three types of special permission bits that we may set on executable files and shared directories. These special bits will make the files and directories to behave differently for certain access operations. These bits are called the set user identifier, abbreviated as setuid, the set group identifier, abbreviated as SGID, and the sticky bit. Let's focus on the setuid bit first. The setuid identifier bit is used on executable files at the file owner level to provide non-owners the ability to run the executable file with the privileges of the owning user. The owning user usually has an elevated privileges on an executable file. As far as the use of the setuid bit on directories is concerned, please note that setting this bit on a directory has no impact. Let me use the screen command and split my screen into two virtual terminals. Control A, Shift S to split the screen. Control A, Tab to switch to the new virtual terminal. Control A, C to start the shell init. Let's SU into user 1 in the new screen. Okay, so let's use as an example the popular switch user command called SU. Control A, Tab. Where is SU? Run the LL command on user bin SU. By default, this command is owned by the root user with setuid bit enabled on it. Notice that there is an S at the file owner's execute level. This letter indicates that the file has a setuid bit set on it. Now let me use the SU command to switch my ID to the root user. Control A, Tab, SU dash, password for the root user, and I become the root user without any issues. This implies that I, as a regular user, executed the SU command with the file owner's privileges, who in this case is the root user. Now I'll remove this bit from SU and replace it with the underlying execute bit. U minus S user bin SU. LL user bin SU. We still see the execute bit on the file for public users. Now let's try to run this command again as user1 and see what happens. su dash password for the root user, and there is an authentication failure message even though the root user password entered was correct. This happened because user1, who is a normal user, was unable to execute the code within the su command that requires the file owner's privileges. Before we go any further, let's put the bit back on the su command. Control A, tab, chmod, u plus s, user bin su, and verify. We can also use the digit 4 instead of u plus s. We can also do chmod 4755. 755 means read, write, execute for the owner, and 55 means read and execute for everybody else, including the group members on the system. So chmod 4755 user bin su. So either you use the chmod u plus s or chmod 4755, both will produce identical results. Now, if you wish to search for all the files on the system that have the setuid bit enabled on them, you can use the find command. Find root directory -perm option and -4000. 4 represents the setuid and 000, I don't care what permissions are at the user group and owner level, and pipe it to more. As you can see, there are a number of files: the mount command, the chh command, the gpassword command, new grp, the su command, umount, sudo, etc., etc. There are quite a few. Similar to how setuid works, the setgroup identifier bit also operates in the same fashion on executable files, but for users who are not the member of the owning group. We can also use the find command to search for files in the system with this bit enabled. Find /-perm -2000. We use the digit 2 when dealing with setgid. And the output shows several files with this bit set at the group level as indicated with an S. One of the files listed in the output is the vol command, /usr/bin/ball. The vol command, as you might know, is used to send a broadcast message to all the users on the system that are currently logged in. Let's run this command as a regular user, user1, who is currently logged on into the second screen. Control A, tab, vol, and let's type a message. This is a test message. Enter, and as you can see, it prints on my screen as well as I'm logged in, and also on the original screen where the root user is logged in. Now let me take this bit off. Control A, tab, to go to the root screen, chmod G-S on /user/bin/ball command, and to verify, and the setgid bit is off. Now let's try running the vol command again as user1. Control A, tab. The command did not work. Let me put this bit back on the file before we proceed any further. Control A, tab. chmod G+S user bin vol. Or we can also use chmod 4555 user bin vol. To confirm the permissions, oops, I made a mistake. this should be chmod 2555. So let's take the setuid bit off and verify. So it's back to its original permissions. The other use of the setgid bit is on directories, in which members of a group want the ability to modify files owned by other group members. This is also referred to as group collaboration. With this bit set on a directory, files or folders created in that directory will automatically inherit the permissions set for the owning group at the directory level. Let's see how it works. Let's create a group called sdatagRP with GID 9999 on the system. Group add -G 9999 sdatagRP. Group is created. Let's create two user accounts called user 100 and user 200. User add, user 100, user add, user 200, and assign them passwords. Password echo user 1234 pipe password command --std in to user 100 and the same password to user 200. Now make both users members of the sdatagRP group. User mod -uppercase G sdatagRP user 100 and also user 200. Now create a directory called sdata at the top of the directory tree, mkdir/sdata. Set the owning group to sdatagRP, chgrp sdatagRP on /sdata directory, and enable the setgid bit on sdata. Chmod G+S/sdata. And add full permissions for group members. Chmod and let's remove permissions for everybody else from the directory. Chmod other -RHCSA. Let's reconfirm. Okay, so the owner has full privileges and group members have read, write, and setuid bit on the directory. All done. Okay, now let's test it by creating a file as user 1 and try to edit it as user 200. So switch into the user 100 account, cd into the sdata directory, and create a file here. File, touch file 100, and the file is created. The ownership belongs to the user 100, and group membership belongs to the sdatagRP, of which user 200 is also a member of. Now let me switch out of user 100 and switch back in as user 200 and cd into the sdata directory. So there is a file here. Let me open this file as user 2 and try to modify the contents of this file. I am modifying this file as user 200 even though it belongs to user 100. :X, save the file and exit out, and as you can see, the file is modified as user 200. So user 2 was able to modify the file that belongs to, or the ownership belongs to, a different user. Similarly, if user 200 creates a file here, then user 100 will be able to modify it as well. Now, if you add any other user to the sdatagRP group, that user will also have the same access on this shared directory. The third special file permission bit, called the sticky bit, is used on shared or public writable directories, and the purpose of setting it is to disallow non-file owners from deleting or moving files that are owned by other regular users. Please note that the sticky bit only works on writable directories and it has no role to play on files. By default, this attribute is enabled on the /tmp and /var/tmp directories, as these directories are accessed by both normal and application users. ll-d/tmp and ll-d/var/tmp. The letter T at the public execute level identifies this bit. We can use the chmod command to set or unset this bit, just like the setuid and setgid bits. Let's take this bit off of the /tmp directory. chmod o-t/tmp, and the bit is off. Now I'm going to log in as user 100, and I'm going to create two files called delete 100 and don't delete 100 under TMP. Control A tab, exit, su-user 100 /tmp, touch, delete 100, touch, don't delete 100. So I've created these two files in this directory. Now I'm going to switch into user 200 and then cd into the TMP directory, and I'm going to try to remove delete 100 file, rm-f delete 100, and the file is deleted because there is no protection enabled. Now let's put the sticky bit back on /tmp and then try to delete the other file as user 200. Control A tab to go back to the first screen, change mode O+T/tmp. The bit is back, as you can see. Now switch to the other screen, Control A tab. I'm currently logged in as user 200. I'm going to try to delete the don't delete file and see what happens. It says operation not permitted. So the permissions are denied. We can use the find command again to search for directories with the sticky bit enabled. Control A tab to go back to the root screen, find /type d -perm -1000. We use the digit 1 when dealing with the sticky bit. Pipe more. And as you can see, /var/tmp/tmp and a few other directories have this bit set by default. This concludes the overview and use of the 3 Linux special file permission bits. For more information, please refer to my book, RHCSA and RHCE Red Hat Enterprise Linux 7 Training and Exam Preparation Guide for Exams EX200 and EX300 3rd edition. Thank you for watching this video. Bye now.